Can we start our section number 3? This is emerging trends and technologies in IT application, which included in our big conference. This conference is IEEE conference, international conference on smart information systems and technologies. Is the start, and first article is number 34. Is can you demonstrate and can you present us your research? Thank you so much.
Good afternoon, everyone. I'm so sorry I have some problem with my camera. Is it a problem to you if I just demonstrate my presentation?
Maybe you can make your report later when you fix your problem with your cameras.
Okay, I can try.
Dear Mahabat, this is one of the main requirements of our conference to turn on your camera. Okay? Can you make solution about your problem, and we move your article in the end of the viewer. Thank you so much. The next presentation. Number 5. Is next article.
Sorry, I'm here. I need a couple. What? Sorry. Sorry.
Thanks. Next paper, ID paper number 55. Matthew Martinez Henry, please.
Okay, hello. Can you hear my sound clearly?
Yes, okay.
Okay. Okay, so hello everyone. My name is Matthew Martinez Henry. I am from IPB University School of Data Science, Mathematics, and Informatics from Bogor, Indonesia. I, on behalf of the other co-author here, will present our research, integration of MobileNet SSD and Acceleration Forest as a prototype of web-based chicken movement anomaly detector. Okay, so as an introduction, in animal husbandry, there are 5 guiding principles of animal welfare, according to Terrestrial Health Code 2021, which are freedom from hunger and thirst, freedom from discomfort, freedom from pain, injury, or disease, freedom to express normal behavior, and freedom from fear and distress. However, 2 studies found a violation of animal welfare in poultry farming. It starts by continuous feeding on broilers, which results in the broiler weight increasing rapidly. And it then results in the broiler having a difficulty moving to take the nutrients to the food and the water nearby. And at the end, it results in the broiler sickness and death. And this violates 2 of the guiding principles of freedom from pain, injury, and disease, and freedom of hunger and thirst. And we have previously proposed an AI solution for this. This work has been documented in Kuronisa in 2021. So, given a surveillance video of a chicken roaming freely or in its coop, we employ a pre-trained model, a MobileNet SSD, to detect the chickens on the video in each frame, and then we will assign a tag, and we will do an object tracking here using a simple Centroid tracker. And this is the result. This is one example of the chicken movement plot we recorded. And we continue the research in 2023 by substituting the simple Centroid tracker with the simple online and real-time tracking algorithm. And we also add the anomaly detection module, which is the isolation forest algorithm. The function of this module is to detect which chicken is having difficulty moving. And we will have this table here corresponding of ID and anomaly score. Anomaly score of 1 means that the chicken is okay, it's not having a difficulty moving, while -1 is vice versa. So we'll know that from the given surveillance video, there are 3 chickens that having a difficulty moving. The work has been documented in 2023 in the work of Karunisha. But the problem now is that both solutions from 2021 and 2023 are not integrated. So in this study, we will build a web application to integrate both solutions. We will integrate the MobileNet SSD and the Centroid Tracker module from Karunisha in 2021 and the Isolation Forest module from Karunisha in 2023. And the development of the user interface is beneficial to boost the practicality of the integration utilization. The web prototype allows the user to input a video only of the burrow surveillance in its scope and automatically receive the outputs. And the output consists of the video with the Centroid tag attached to the broiler and the broiler movement plot from the work of Karunisha, these two, and anomaly detection inference result on each stacked broiler from Karunisha et al. 2023, this table. And in order to develop that, we use a framework, the Flask framework, and the Python libraries, NumPy, Pandas, Matplotlib, scikit-learn, dlib, SciPy, OpenCV, etc. And for the development of the user interface, we use vanilla HTML, CSS, and JavaScript. Before we dive into the result, we have the proposed solution from other studies as well. It's good to know that burrow detection and tracking using YOLO and BotSort have been done previously by Siriani in 2023, and similar study have been done by Donwit in 2024. But BotSort here is substituted with sort. And we also do a they also work by Trianto doing a comparative analysis. They employ detector and tracker, and each detector is paired with each tracker to determine which are having the best performance. This is the references. And so now we on to the result. We have the integration flowchart. And so right from the start, we will insert the MP4 video and we will read the whole video frame. And in each frame, we will do a burrow detection. We employ MobileNet SSD here. And then we will do a tag assignment. And then we track the broilers using the simple Centroid tracker. And by the end of the video frame, we will save the video with the tag attached, create the broiler movement plot, and detect the broiler movement anomaly. And all these results will be displayed on the user interface. And for the user interface development, the user here is the livestock farmer. And it is actually simple. The prototype is actually simple. The user will only need to input a burrow surveillance video here and wait for it and can download the result. And in the background, we will done a burrow detection, tracking, and movement anomaly detection. It is done by the service we developed. And we develop a 6 class diagrams here. We will have the video class. The video is processed by the MobileNet SSD, which results in the table output. This table output is not the anomaly detection table. This is the intermediate result from the MobileNet SSD, which is processed by the isolation forest algorithm to create the final table. And this MobileNet SSD is composed of Centroid tracker and trackable object. And so these two classes lives in the MobileNet SSD. So if the MobileNet SSD is instantiated, these two classes will be instantiated as well. And this is the user interface. We have the home page. We will actually serve 3 services here, but the scope of the study is only one for the chicken movement anomaly only. If we press this button here or from the left tab, we will be sent to this page. to upload the video. And the user can actually just upload the video, an MP4 video, and receive this result. This is the video. And then the ticket movement plot I told you earlier, and the anomaly table. And we will do a functionality testing as well. And so if the user press the ticket movement anomaly button, it will be linked to the upload video page. And if the ticket movement anomaly button is pressed again on the left tab, it will also link to the upload video page. These two are accepted, so it means that it works as expected. And if the user upload the video button, it will access the local file to insert a video, and run the detector button. It's also work as expected as well, and also when downloading the results. And so this is the video to show to you all. Okay, we can upload the video here. Just press upload video and then run the detector. We wait for a while so the video can be processed and it will output the result. Okay, so this is the example result. You have the video and with the IDs attached to its chicken. If the chicken is moving, the ID is moving as well. Okay, this video takes 3 minutes. I will not show it all to you. Now we have the chicken movement plot as well. We have 6 chickens detected, so we have a lot of IDs here, each representing its chicken detected. And we have the anomaly table as well. And one chicken are detected as anomaly. We can download the result on a zip file. Okay, so that is my presentation. Before I open for a question, I want to acknowledge on behalf of the other co-authors as well that this research is funded by the Ministry of Education, Culture, Research and Technology from Indonesia through the Directorate of Research and Innovation from APB University with the research grant ID attached. Thank you for listening.
Thank you so much. Do you have some questions? I have one question. Dear Matthew, I want to ask about your database. How many data you have in your databases, and which type of database you use in your research? Oracle, SQL, maybe. Why you choose this database?
Okay, so since this is only a prototype, so we haven't employed it to the database. We just save the data to a local server. At least for now. But for the database, we will that will be our next project, our research project, employing this to a database.
What do you think about using the types of artificial intelligence instruments in your platform?
Well, the AI instruments I use here is the mobile.ssd. So it is actually the work from our previous work, mobile.ssd, and then we have the anomaly detection algorithm This is the AI that we use. But our study here, our focus here is to build a web application representing the prototype for integrating both solutions. Because these two flowcharts are not integrated. You see here that we don't have any isolation forest algorithm attached to this solution. And now we attach it on the other study. But this other study using the simple online and real-time tracking, which is time consuming. So for the sake of prototyping, we employed the simple centroid tracker.
Yes, thank you so much.
Dear team, thank you for your presentation. My name is Anna Jumar, and also your research is close to our and represent the Agritech Research Innovation Center. And I have one question. Can you tell me what's the kind of key challenges you have met during your research?
I'm sorry, I cannot hear you well. Can you repeat the question?
I mean, can you tell me, can you hear me now?
Yeah, I can hear you clearly. Yes.
Okay, is good. I said that your research area is close to our research areas because I'm representing the Agrotech Research and Innovation Center in Astana IT University. And can you tell me what kind of key challenges you have met during your project?
Okay, so I think the challenges is on integrating both solutions, the key of this study, because it is written in imperative language, and we have to change it to an object-oriented programming language. Not language, but style, object-oriented programming style. And I have to select like the reason why I want to actually at first I want to employ the SORT, but when I run the application, it becomes very slow. SORT has like cubic complexity according to time, so I need to change it back to simple centroid tracker, and that is really challenging because at first it would be very easy if we just use SORT instead of simple centroid tracker, because I have to change some lines of code and integrate the solutions again.
Hello, can you hear me? Hi.
Yeah.
I am Leila Zaeva, and I didn't find your presentation like financial or economic impact.
I'm sorry, I cannot hear you clearly.
I didn't see the benefits after integration this system in the real, in the real farm. So have you compared situation before implementation and after? I mean, do you have
Yeah.
any real impact of this research in the real farm?
Well, it's very far from now. We still don't have any database like I have mentioned previously, and yeah, we haven't tried on the real farm. And if you see, our limitation here is that we developed this prototype using Python, which is we think not suitable for in the backend side when we want to employ this, when we want to deploy this in the real farm. We haven't reached that stage yet, but we will reach that stage, I think, in, I don't know, 3 or 4 years.
Okay, good luck in your research. And thank you so much. Wishing you good luck in your research.
Yeah. Thank you.
So IP34 fixed the problem with the camera. I think we can look for this. Or
Yeah.
Mohammad, if you are ready, please, you can start your presentation.
Yeah, I'm here. I found another laptop, so.
Mohammad, before you start, I just remind you again, yes, and all participants that our presentation is allocated only 7 minutes, okay? Thank you.
So sorry, it's very hard to hear you.
Okay, you
Could
can
you
start,
please?
Mohammad.
Okay. Thank you. So, good afternoon, everyone. I am Mohammad Bahed, and I will present our research on high-speed data transmission and encryption from low-orbit satellites for forest monitoring and forecasting at this conference. And oops. Forest fires cause substantial environmental and economic damage, and it's necessitating accurate and timely detection and forecasting. And our work addresses effective data transmission from low orbit vehicles to support these systems. And this slide contains a photograph of a forest fire. And what are the main environmental impacts of forest fires? That they include the destruction of ecosystems, loss of biodiversity, and release of greenhouse gases. In the next slide, we emphasize the role of low orbit vehicles and advantages of these aircrafts. They offer for Earth observation higher spatial and temporal resolution, wide area coverage, and cost effectiveness, enabling detailed and up-to-date information for forest fire monitoring. And in this slide, you can see ground-based aerial and low-orbit observation methods. Why is higher temporal resolution important for fire monitoring? Because it allows for frequent updates to track fire spread and provide timely warnings. In this slide, we demonstrate existing solutions and limitations, while unmanned aircraft vehicles and deep learning are used in environmental monitoring. Secure data transmission from low-orbit vehicles remains a challenge. Current solutions often address monitoring, forecasting, and data security separately, limiting integrated systems. So this slide shows a diagram of existing fire detection systems and the limitations of using WAVs UAVs for forest fire monitoring. It's that they have limited flight time and range compared to satellites, restricting their coverage area. And in this case, we propose integrate the BB84 quantum key distribution protocol, convolutional neural networks or CNNs, and a geographic information system to enhance security, efficiency, and data management. And in this slide, you can see a high-level block diagram of the proposed system and why we choose BB84 protocol, because it's a quantum key distribution protocol and it can offer high security based on quantum mechanics. And the research objectives first of all, analyze modern data encryption methods and develop high-speed data encryption based on quantum cryptography, and develop GIS for monitoring and forecasting, combine encryption and data processing, and finally evaluate the effectiveness of this approach. And which modern data encryption methods were analyzed? There were AES, DES, and RSI, such as common cryptographic symmetric and asymmetric algorithms. So our solution employs the quantum cryptography, as I said before, for the data encryption, and this it can offer higher information protection. In this slide, you can see a simplified diagram how BB84 protocol works, and the properties of quantum mechanics like superposition and entanglement to secure communication. It can be benefit of quantum cryptography, while classical cryptography relies on mathematical algorithms. And the key features that BB84 includes qubit transmission and measurement, comparison of basis for shared key establishment, and high security without requiring a pre-shared secure channel. And in this table, you can see the basis, bit, and polarization state of qubit. And as we know, a qubit is a quantum bit which can exist in a superposition of 0 and 1, unlike a classical bit which is either 0 or 1. So is convolutional neural networks are used for intelligent data processing. CNNs effectively analyze remote sensing data and identify patterns related to forest fires, and they consist of convolutional, pooling, and fully connected layers. And this slide shows a simplified CNN architecture and what are the advantages of using CNNs for image analysis, because it can automatically learn and extract relevant features from images, making them well suited for tasks like object detection and classification. In a geographic information system combines monitoring, forecasting, and encryption, and this system stores, processes, and visualizes spatial data, displaying remote sensing data, visualizing neural network analysis, and managing data encryption. And this slide can show a screenshot of a GIS interface displaying file locations. And the key functions of the system in this context, it can provide a platform for integrating and visualizing spatial data, enabling better situational awareness and decision making. And in this slide, we show the result of a comparison quantum cryptography with AES and DES algorithms, and we can see that quantum cryptography offers theoretically superior security, but has higher implementation complexity. And what are the trade-offs between security and implementation complexity? Generally, high security comes at the cost of increased computational resource and technical challenges. And to evaluate our method, we used Landsat 8 remote sensing data, evolution metrics, data transfer rate, encryption, decryption time, and error probability. The CNN implementation used Python with TensorFlow and PyTorch. GIS analysis was performed using ArcGIS and QGIS, and encryption, decryption time measurements used a system with an Intel Core i7 processor. And in this diagram, we can see the experimental simulation framework and why the Landsat 8 we chose because it can provide high resolution, publicly available remote sensing data suitable for fire monitoring. So in the result, quantum cryptography maintains a higher data transfer rate than IS and DES, especially at higher loss levels. And how does photon loss affect the data transfer rate? It can reduce the signal strength and increase for the error rate, potentially decreasing the data transfer rate. And BB84 has faster encryption decryption times and lower error probability than traditional methods. What are the implications of the lower error probability? It leads to more reliable data transmission and improved accuracy in fire detection. And in conclusion, our method provides effective high-speed and secure data transmission, quantum cryptography, and neural networks from a powerful solution. Future work will explore other quantum algorithms and improve forecasting accuracy. We utilized Landsat 8 data and Python with TensorFlow, PyTorch, and future research will investigate scaling of the system and addressing security threats to quantum crypto systems. And the challenges in implementing quantum cryptography in real-world satellite communication, that they can include maintaining quantum coherence over long distances and atmospheric interference and the complexity of quantum hardware. So in the short, that's all that I wish to share with you for today.
Thank you so much, but unfortunately, in your presentation, I hear the people who are going instead of you, and this is first. And second, I have several questions in your research. First question is how you use quantum cryptography. I don't understand why, because quantum cryptography based on just only fiber optics. But your research in focus is based on wireless technology. How you use the quantum cryptography in the focus and in the wireless technology? Because it's absolutely not existing technology now. Second question, why you compare the algorithms like DES and IS with quantum cryptography, because this is absolutely not compared algorithms, because this the main function of our IS and this algorithms is very difficult if comparing with the principles of quantum cryptography. Quantum cryptography is based on the lights which are going in the fiber optics channels. Can you explain me, please, your research? Because your research
Yeah. Thank you for your questions. First of all, we try to use quantum cryptography to encrypt data transmission from low orbit aircraft, and it's not to do forecast. We integrate geographic information system with quantum cryptography in light of encryption, data encryption. So quantum cryptography we plan use only to encrypt data. And the second question was why we compared quantum cryptography with traditional symmetrical and asymmetrical algorithms, because as I said before, we nowadays to encrypt data in common, we use AES algorithm, yeah, or RSA to such electronic digital signature, yeah, and these algorithms. Common algorithms that we use nowadays, and we try to show how implementation of quantum algorithm can offer huge benefits to encrypt aircraft data.
Yeah, we will have some questions. No questions. Okay, thank you so much for looking in. Thank you so much, Mohammed. Please, next.
Thank you.
ID number.
Sorry, please don't forget about time limit, okay? Up to 7 minutes.
Hello, audience. Today, I'm honored to present our research on the topic of relating the performance of Kubernetes orchestrated multi-agent systems. We conducted a case study on University Coast timetabling. We conducted this research with my scientific supervisor, Volodymyr Malakov, and my name is Akshay Kazis. So let me introduce you to this topic. First of all, we approach to the multi-agent systems design approach. This provides us the decentralized problem solving for such complex tasks. The problem we conducted is University Coast timetabling problem. The short name is UCTP, and is well known in P-hard optimizing challenge. The key technologies we use during this research is Kubernetes, parsing, and for containerization is Docker. And, our study focuses on Cloudmark framework to introduce our research to cloud-native technologies such as Kubernetes. Below, I showed you the infographic about the difference between centralized and decentralized multi-agent systems. As you can see, there is a number of agents that are controlled by one center of decisions, and others. There is cluster of agents that communicate with each other, make decisions, and one control center just tracks and manages it. Let me introduce you to the research context of my research. Traditional multi-agent systems usually have some challenges and problems with stability, fault tolerance, resilience, etc. But with introducing containerization and cloud-native technologies, we have opportunity to scale our systems globally and use global solutions, for example, Amazon Web Service. And for example, Kubernetes technology adds automated orchestration, self-healing mechanisms, and actually resilience. What was the research gap for our research? First of all, this research field is not covered as well as other AI fields, and there is actually limited understanding of how this infrastructure affects on the multi-agent system. There's only a few studies on kind of metrics or how this architecture affect on communication efficiency, resource allocation, resource utilization, and stability. So we needed some quantitative research that will allow us to compare the techniques during the implementing multi-agent systems. So we defined two main research questions. First question is what's the relationship between the number of clusters and containers and mass performance, and what was the key trade-offs between the execution time, resource usage, and communication overhead. Let me introduce you to our system architecture. As you can see, we have one environment. One environment can be scalable to multiple instances through containerization and clustering. We have a message broker. We use submarine input-output message broker. This message broker used to for cluster intercommunication. We have a distributed key-value database. We use Redis for saving agent states. We have Logger to log the resource utilization. We have service registry for agents. We have an agent management service that manage all these agents in different classes and containers, and one single database for knowledge. Let me show our methodology during our research. First of all, I want to cover the experimental design. We used a well-known dataset for University scientific problem. It's Unitime University scientific problem benchmark. Actually, I use most advanced CA. Our hardware, and I want to move to the hardware. We have two identical machines based on Intel Core i9, 12th generation, 32 GB of RAM, Ubuntu Linux system for both of the machine, and Kubernetes version of 1.26 stable version. And I use Go language latest. So let me show our experimental scenarios. We have three main scenarios. First of all, we name as baseline performance. It's kind of single cluster with 10 containers, and it needs the scenario needs to show baseline metrics for future comparison. Then we scale a number of containers from 10 to 20 to 50 and to 100. This scenario shows the impact on execution time, resource usage, and communication. Then we need to move to scenario number 3. It's about multi-cluster scaling. So we scale the clusters from 2 to 3, 4, and 5. These average each containers distributed equally for each cluster. And this shows impact on the also on latency, execution time, and resource distribution in current classes. What metrics we have gained is first for execution time. We need total time for completing this problem. Actually, it is timetable generation, and we bracket the time initiation cycle. Then was resource utilization. We track the CPU and memory usage for each container, and kind of cluster-wide resource efficiency. Then there was communication overhead between each agent and cluster. Let's move to the results we gained. On the first figure, you can see that there is steady, let's say, you can see that the execution time decreased steady during the increasing of the containers, but after 15, after 20 containers, there is drastic, and after the next step, it's kind of hit the plateau and didn't change much. On the next figure, you can see that wasn't much effect on the memory utilization for each container. And for the last figure, you can see drastic increasing of the latency between edge communication. Let me move to the multi-cluster scaling results. It's actually scenario number 3. On the first graph, you can see the scaling results of execution time of the table generation in hour scale. For one cluster, it was 6 hours and 55 minutes. And by increasing the number of clusters, they kind of simultaneously decreasing and increasing of execution time above like 6.5 hours. On the next figure, you can see that kind of decrease of the percentage of resource utilization for each cluster, but it's not classical because it went from the 80 to 70. Then let's move to the latency. Latency of message message communication between clusters. It went from the 15 seconds to the 100 seconds for message communication between the clusters. So what key trade-offs we gained from the research? First of all, for container scaling, actually is good for execution time reduction, the efficient of resource utilization for each container, but we have some limitation with communication on heap. For cluster scaling, there is kind of better resource distribution. Yeah, so if your research is focused on the resource allocation, you can try the next techniques for resource distribution. Then it enhances fault tolerance because Kubernetes have made already built-in fault tolerance techniques, and the key trade-offs of cluster scaling is higher inter-cluster communication latency. What was the practical implication of our research? Actually, this research is applicable for moderate workloads. We can scale our system for around 50 containers per cluster. It's actually a good result, for my opinion, from our research. And for larger workloads, we need to configure clusters manually for better fault tolerance and latency. So we recommend you the hybrid approach. So you will combine the container and cluster scaling both, one with manual balance. So to wrap up our research, actually, containerized multi-agent system provides some benefits for both solving complex problems such as UCTP. However, it has some key trade-offs on the latency and communication key between agents. For example, I provided exactly number like if we improve our execution time by half by increasing the number of containers, there is actually increasing of latency like 2 times when you increase the number of clusters. So these trade-offs are actually clearly show that execution time and communication is a key problem on such things. So thank you for your attention. Have some question. My pleasure to discuss it and answer.
who are doing the license. Was it
We did short because I already use the system on the small, scalable, platform. I kind of solved it in my previous research. I published them for version as well. Find the system here, but in this research, I kind of scaled this system widely, like to 100 times. Because my system was like on single instance, but here I use two instances and public. Actually, I'm planning to continue my research on protocols to reduce the execution time and communication between clusters and containers. As I mentioned before, it was the main limitation. And I'm planning to receive this research in my research degree next year's. Yeah. Application. Did you discover that as you scaled it up, you actually got better performance in some instances? Or the performance degraded constantly as you scale it up? Yes. No, it's not. Performance actually increased. As you can see, the execution time decreased. So the system generated the timetable in less amount of the time. For example, this 50 containers, the system took only 7 hours to generate timetable. So as you scale it up below, yes, you actually got this performance. Yes, but I have trade-offs on the inter-agents communication. And of why, because logically, one would think that if you scale up below, the system would be less. I think that have you any indications why this phenomenon? Yes. While you increase the number of containers, your kind of computational workload increase, and you can compute this timetable faster, but you cannot communicate with other agents as effective as before because of the increasing of containers. So there is kind of inter-containers latency and inter-cluster latency. And the communication was the inter-container latency. Therefore, there is a kind of plateau after after some number of containers. And to kind of break this plateau, I'm kind of interested to design new protocols for inter-container communication cluster.
someone there,
So next, paper under ID number 76, please. Five, yeah.
Hello everyone, I'm here.
the step. Next.
$76. $76, Ivan Apirsky. Okay, 75.
Do you hear me?
Yes. Can start.
Hello, everyone. Let me introduce myself. My name is Sajvar Armankadze. I gonna be polite from Eurasian National University. Today I will present CareRocket, our system for animated biometric QR codes that enable secure real-time authentication. Okay. In this slide, let's begin with problems QR codes. Static QR codes can be easily copied or photographed and then replied to the attackers. Transmission-led biometric details over networks introduces additional threats, maybe vulnerabilities. And because static codes never change, you can't enforce a real-time validity window. We can saw here and the need for a mobile-friendly, time-bound biometric QR code solution, hence AV QR codes, animated biometric QR codes. Next is in this table, we can see static and animated QR codes comparison between them. Static QR codes to our animated biometric QR codes. Static codes lack of biometric embedding, have no time limit, and can be replied identifiably. Animated biometric QR codes frames are using asynchronous encryption, IS encrypted, refresh every 1 or 2 seconds, embed facial templates, and reply to attackers, toward replied attackers. Next slide. General scheme for generating AV QR codes, animated biometric QR codes. Here is overall pipeline in this picture. First, the mobile app captures the user's facial image and ID data. Next, our QR generator creates a sequence of frames, each tagged with unique UUID, universal unique identification, and the timestamp, then encrypted each with IS codes. These frames animate on the user's devices from the AV QR's stream. Next is generating animated biometric QR codes for biometric authentication. This flow chart details for authentication process. Each QR frame is valid for only 1-2 seconds and carries a facial template, session token, and timestamp. The mobile app and the server stay synchronized. The server decrypts each frame. Then verify the timestamp, matches biometric data and issues, and access decision in real time. Next example, animated biometric in action. In the case, we can see a user approaches a secured door. The mobile app generates an animated biometric QR codes on demand The portal scanner reads each rapidly changing frame and verifies identify on the server. Because because the stream of QR code updates dynamically, then reply or cloning attacks became practically impossible. You can see here. Next flow chart. Next diagram, we can see here creating using AB QR code user interaction flow workflow. This activity diagram on outline and to end user interaction. After registration, the capture of the face and the storage on our database. The user's device performs local biometric matching, generates the animated QR stream. The portal scans and authenticates each frame. And finally, all events are logged for auditing. QR Rocket system usage charts. Next, a workflow chart. This flow chart we can see 3 actors: administrators configure a system, then users enroll and authenticate, and the portal handles scanning and server communication. Data flows through our REST API stored in MongoDB. And the facial biometric are processed by Face SDK and OpenCV process. Next is here we can see algorithms of the portal for creating QR codes. On the portal side, it continuously scans incoming frames, forwards them to the server, and displays the access results. In the mobile app, we capture a fresh face images, generate a new time-bound QR sequences on demand, then update frames in real time. QR generation logic system architecture. On the left is the QR generation algorithm, figure 9. Take biometric and session date, encrypt with IS timestamp, assign UUID, universal unique identification, and appearance of the frame buffer. On the right is our overall architecture. Cross-platform mobile apps is a Python REST API, MongoDB, Face CDK, OpenCV, and admin portal, and the eGov integration. Next, Rocket interface. Next steps. UI. In this slide, we can see finally here is our mobile UI preview, showing the live animated biometric QR codes, playback, and history log. QR Rocket provides strong security real-time validation and multi-factor support. Our next step is include integrating with national ID, electronic ID, integration, cryptographic enhancements, large-scale trials. So this is reference. Thank you for attention. If you have any questions, happy to take your question.
Thank you so much, Ajay.
Thank you.
Dear colleagues, do you have some
Thank you for the presentation. I have one question. You represent your solution, yes, for QR codes. And I just want to know, can your solution can be integrated to our electronic government platform?
Okay, thank you for your question. We have created an algorithm that's nearby or close as possible to the algorithm of the government system. We are currently testing this process on the platform. The system can be integrated with existing information system, which provides convenience and give scalability our future.
Thanks for that.
Thank you.
Okay, dear colleagues, I want to ask some questions. What you demonstrate us the pictures and QR codes. Yes, this is very different types of data because pictures is more. The weight of the pictures is more than QR codes. How many data you have in your database in the picture form and in the QR form?
Okay, thank you for your question. The system combines an increased level of security and transmission of large amounts of data over the network. Or, for example, mobile network is optical network that matter in a compressed form, a convenient data transmission over the network. Hence, the system achieves an increased level of security due to dynamism, for example, by collecting graphic files, PNG, JPEG, and others, into to GIF is also to store compressed data without loss of quality and uses LZY, Leibniz Welch compression. This is a type of algorithm which allows you to compress files.
Do you have some questions? Okay, thank you so much, Ajat.
Thank you. Thank you.
So next paper ID is 76, but it should be. Yes. We can continue with the paper number ID 93. Dariga, yes?
Yes. Do you hear me?
Yes.
Okay. My screen is visible. Okay. Can I start?
Yes.
Yes.
So, hello everyone. My name is Dariga Sadarkuraeva, and I'm excited to present our project titled DAO-SAM, Development of a Translator for Kazakh Sign Language to Speech using gesture recognition. So, this project was developed as part of our research at the International IT University from Almaty. So, let me begin by explaining why this project matters. Today, more than 200,000 people in Kazakhstan live with hearing impairments. For many of them, communication remains a major barrier in everyday life. Whether it's in education, public services, or the workplaces, one major challenge is the lack of effective tools that can translate Kazakh Sign Language into speech. This gap motivated us to take action, and our main project objective was to build an inclusive real-time translation system, which we named DAO-SAM. From the Kazakh language, it's translated like my voice. It's powered by AI and designed especially to recognize dynamic gestures of Kazakh Sign Language and convert them into spoken output. The main idea of project is make communication more easier, faster, and more accessible for people who rely on sign language in their daily lives. So this is our system architecture. The process begins with the video input from a webcam. And we use the MediaPipe heuristic to detect hand and face landmarks in real time. These gesture features are then through a hybrid model combining CNN, GRU, and attention mechanism, which allow the system to both understand spatial movements and track the temporal sequence. Finally, the recognized gesture is converted into speech through a text-to-speech synthesis. And to train this model, we needed reliable data. We recorded 12 dynamic gestures from 4 volunteers, producing 1,200 gesture sequence, each made of 30 frames. From every frame, we extracted 33 hand and 468 face landmarks from each sequence, which were stored in NumPy arrays. And we used 80% of the data for training and the remaining 20% for validation. So let's now look at how the model was designed and trained. Our CNN lawyers extract special features from the gesture frames, and GRU lawyers, we used GRU lawyers to capture the movement pattern over time, and the attention mechanism allows the model to focus on the most meaningful parts of the gesture. And we trained it using the Adam optimizer, which categorical cross entropy loss. So this is the results of our model. Our model reached a training accuracy of 98% and a validation accuracy of over 96%. And in terms of performance, it achieved 97% precision and over 96% recall, showing high reliability in recognizing gestures. So, but beyond technical performance, we also wanted to measure social impact. We surveyed 140 people, and their responses were encouraging. By the result, almost 46% of them said the app would help them in everyday communication, and most of them is ready to use app like this. So this is our project, how will look like. The first is camera will request to accepting, and after the user can show their gest, and system will recognizing, and after give the result in speech. So, and we already have a plan for future development. We aim to introduce text to gesture translation using animated avatars that can sign in KSL. We also plan to incorporate neutral language processing to understand to understand sentence structure and improve communication flow. So to conclude, is DAWSOM is not just a research project. It's a step toward a more inclusive and accessible society. It shows how AI can serve real human needs and help people who often go and he to finally have a voice, create literacy. We proud of what we've built and believe it has strong potential of growth and impact. So this is our all reference. And thank you for attention. That's all.
Maria, Gideon, thank you so much. It was a really interesting presentation. Do you?
What is it? What microphone?
So yeah, Gideon, thank you so much for such a hardworking project that you're working on. My question is, by looking at your training data set, I wonder how long have you been training it in terms of number of epochs? Would you be? I mean, I'm just hoping that there was no overfit over the data set, the training data set.
Can you?
So my question basically is, I don't think there was a slide or any figure showing the length of training your data set using CNNs. So more specifically, how many epochs did you guys try to target? Thank you.
At the first we started with 20 essential dynamic gestures, and we recorded 120 sequence. In the future, we planned this we plan to the hike the results.
Okay.
Okay.
You can continue.
Thank you so much.
Yes, Darika, thank you for your report. It was really interesting. Let's continue with the ID number 118.
Okay, thank you so much.
118, please. One.
Next one, please.
Wow. 118.
Everyone, are you ready? Everyone.
Good afternoon.
Who you represent this paper?
118. 118.
Okay.
Can you see my screen?
Just please don't forget about your time limit, okay? Up to 7 minutes.
Okay. So good afternoon, everyone. I'm very excited to present our topic called real-time road accident detection using machine learning and audio signals. Today we're going to represent me, Qasımbayev Oljas, and Malik Omar Yerkeblan. So this is the contents and the starting for introduction. I want to say that nowadays about 135 million people die each year as a result of road accidents. So we know that it's like very large number, and in order to prevent it, we considered to make an application using machine learning. So the main objectives of our project is like creating an application for Android and iOS, crash detection using sound analysis, and using machine learning to confirm the accidents. So next one, this is the methods. So first, a data set containing like various real and simulated crash sounds was collected and processed. So we collected our data from the website Kaggle, which called the name of our data set is raw accident recordings in accident and crime detection. It consists of 1,200 audio, which have been divided into 4 main categories, such as car crash, human screams, engine idling, and the background noises. So there you can see the number of recordings, total duration, and the file format of this dataset. So next one is the methods. So we use the convolutional neural network architecture for our audio classification. As you can see, we collect first our raw audio, then we process it, and we turn it into the spectrograms, as you can see in this page. So then spectrograms is like a visual representation of sound in like over time. Also, as you can see, next step is like convolutional layers extract the key features, while subsampling layers reduce the data for efficiency. And the model outputs probabilities for specific sound categories, as I said before, like car crash, engine idling, and etc. So next one is this is the results of our raw data which we processed, and this is the final version in spectrogram. As you can see, it's like frequency and the time spectrogram. First one is the crash. As you can see, this is the red and the blue colors represent the sharp and the powerful spike of the crash. Like it sounded like Bach, for example. So next one is the engine idling. Engine idling spectrograms, it's like shows a steady pattern in the low to mid frequencies, like not very hard sounds. And the next one is the rain. So rain spectrogram displays a uniform and a continuous pattern, as you see in the like red dots. And the last one is the door. This spectrogram consists of 2 short peaks, like opening the door and the closing the door. And all these spectrograms identifies the crash detection.
So good afternoon, everyone. My name is Malik Omar Yerkeblan. So as my teammate said, we are using machine learning to identify the car crash audio. So we divide our machine learning model for 2 submodels. First is just from the distinguish audios between each other. So second sub modeling is by the mathematical metrics. So by using mathematical metrics, we will by applying 2 submodels, we will get more high accuracy in machine learning model. So first is the zero crossing rate. It's a metric used to it's measure of signal. It's like switching from the negative to the positive. So this feature is particularly useful for distinguishing between the speech, music, and the environmental noises. So second is the audio signal. Previous slide, please. So second mathematical metrics is audio signal, power of audio signal. So we expected that crash sound has the more high power. So energy entropy, it's a third measure. the distribution of energy across different frequency components, so which helps determine whether a signal is impulsive, crash, or stationary road noise. So there is the main core of our Sahtan system. It's a backend. So as you can see, we separate each component from each other to get more productivity and efficiency of our application. So as you can see, the first model is authentication model. It's responsible for login and creating new users. So it's the second model, it's the accident detection model. So this model only responsible for recognize the crash sounds, and if accident detection model responds that there is some crash sound, the CERT notification service model will automatically notify the emergency contacts. So next. So there is some screenshots of our application. So as you can see, the first screen is integrated with the Google Map API. So, and in our application, we will add contacts to emergency contacts to send the notification. And the third and the fourth screen, it's like if accident is occurred, the cert in the cert screenshot we can see the timer. So in 30 seconds we will able to respond that if you okay, the emergency will stop. But after ending this timer, our application will automatically send the messages to the emergency contacts or call the 112 like government.
So the conclusion, so as we said before, our application Sahtan is like smartphone applications that detects road accidents using sound and the machine learning. So it's also accurately identifies the crashes and send immediate alerts. So in the future work, we will enhance our accuracy and the machine learning and the real world reliability. So this is the reference. And thank you for your attention, and we will happy to answer for your questions.
Thank you for the presentation. It was very interesting. Could you explain to us what measures you've taken to reduce the possibility of false positives? So, for example, are you basing the alert being raised on just one sensor, like the sound, or are you combining that with other sensory inputs? Thank you.
So as my teammate shows, the spectrogram image it's responsible for this kind of problems. For example, our machine learning model will identify by the spectrogram images, and you can see the differences between the spectrogram images. So our machine learning will only respond for the car crash spectrogram images. Please show the crash spectrogram image. So there is the crash spectrogram. It's different from the engine, rain, or door like. And by implementing this kind of spectrogram, we will reduce the false alerting. And as I told before, we have two sub models. First, it's by implementing spectrogram image, and the second is the mathematical metrics. So not only our our system will how to say, take the results from the mathematical metrics and from the spectrogram model. And if two models responds true, like that, there is the car crash. So our system will automatically notify the emergency systems or emergency contacts.
Here, if I were to record the sound of a crash and play it back in the car, it will generate the alert, right?
So if you scream or if you, how to say, like gunshot in the car, yeah, it will
Okay. It will
generate like a car
generate an
crash.
alert. Okay.
Yes.
Thank you. Thank you.
Thank you so much.
Okay, please, ID number.
Okay, thank you.
Thank you.
Now schedule will have some breaking time. This is coffee break, and after coffee break, we continue our section number 3.
Good day. Can you hear me? Excuse me, can you hear me?
Yeah, we hear you.
Okay, thank you. Good afternoon, the members, commission members of.
Dear colleagues, according our schedule, we have the breaking time. During the 20 minutes, after 20 minutes, we continue our session.
Is that okay? We will continue at 4 in 20 minutes.
Okay, thank you. The title of our research work is Research on the Comprehensive Simulation Testing Platform for Navigation Satellites based on BD3. We are the authors is first author is Lucian Min, Professor Lucian Min, and Professor Zhao Hongwei, and me. The first and second professor is from China, which located in Xi'an City, Northwestern Polytechnical University. I'm a senior lecturer from the Kazakh National University, Nimet Al-Farabi. So about as an introduction, this is with a wide application of BD navigation system in China. The satellite navigation and location service industry plays a main importance of national economy and national defense of constraints. So in this project, our purpose is to present a comprehensive and advanced simulation platform designed to address the operational needs of navigation satellites utilizing the BD3 system. That's why main important part is what is BD3. And so in China, BD navigation system has involved with the form of the demonstration navigation satellite system, BDS first, BDS second, and this application is created by the development of the BD3. So this is continuously evolving the large-scale system with a closely integrated space in the ground component and the development time limit. About our research objects, this is show the firstly data simulation requirement to making a comparison with ARINES, BD3, and GPS. You know that there's ARINES is a global navigation satellite types. There is a different types of the satellite GNSS, the global navigation satellite system divided to BD3 from China, and GLONASS is in Russia, and the GPS is United States. So the second research object is using the space environment parameter simulation, using some two kind of mathematical models, and to making a simulation trajectories using to find errors using the two mathematical models. I will continue explain about it. And there is also using the differently and integrated information. Then navigation message generation. The last research object is observation data generation. This figure first is technology roadmap. Is used to technology for roadmap is for the implementation of the research work there is including the 5 case components of BD3 simulation platform, constellation generation, visual models, and the graphical display, constellation analyze, and the position simulation. So our system is created by this roadmap using technology parts. And about the constellation generation, there is some 6 orbital parameters using essential defined satellite orbits in simulation constellation, and the time-dependent parameters using the corresponding time values in the here showed 2 types of the mathematical modelings. And this first one is Klocker models, and the next one is edge of field models. So we are using these models to find the errors calculating with a delay time and the components of with the different parameters as a temperature, as the evaluation parameters. So this Hopfield model is using these 2 models is playing the most important critical roles in modeling realizing of global navigation satellite system based on BD3. So this is to finding the main resource errors. Using these mathematical models in our article, we clearly and generally explain it, the working steps. For the next is constellation analyzing. There is showed. This figure displays the results, how satellite configuration change over the time and this impact of the system performance that's created with the system. And the next position simulations by the time to points of the our systems working at different types of the simulation calculation by the mathematical models to find errors. And by the conclusion, this project is founded by the China organization, and in the future, implemented the simulation system is developed using the Visual C++ and MATLAB. And there is a Visual C++ is handling the interface, and MATLAB is executed the simulation processing. So this system is working with 2 and 3-dimensional environments. And in the future, we are planning to enhance to simulate, make a prediction using the machine learning and using the real-time data generation. So in the future, we are using some cloud-based calculation and deployment and enhancing the find and the error modelings. So quickly finished our presentation. If you have some questions, you can ask. Thank you for your attention.
Thank you for this interesting presentation. My question, I know that DBS was constructed and implemented by China, I know in the 2016, 2017. So my question is why DB3, first of all, and secondly, my next question is how you wanna implement in future. It could be your research and your project could be like the part of the China global satellite navigation system, or you would like to propose another one, for example, currently to the Kazakhstan or to another place, region. Thank you.
Thank you for your question. So that's why I told about the BD navigation system. The first generating is BD first and second. And what is the advanced of the BD3 is generated and integrated BD BeiDou satellite system. Also generated, there is the RNS, such as this is usage of not only the how can you say RNS, it means it's like the advanced to generate to integrate the GLONASS and the BD BeiDou navigation system. So this is first question, because it's developed from the BeiDou first and the BeiDou second. The second question is, this BeiDou navigation satellite system is developed in China, and that this project is based on One Belt, One. For in the future, we are planning to develop this satellite system not only in China, if it is possible, to Central Asia to implement this system. So this is a part of the project, and in the future we are making improved error handling using the advanced mathematical modelings and to find predictions using the machine learning.
Yes, thank you so much.
Thank you so much.
Next, ID number 58.
Hello, ID 58. Give me please 1 second. Okay, so should I share my screen, right?
Yes.
How do I do it?
You can share your presentation with some.
Yeah, I'm trying to find a button to share the screen.
Yeah, we can share.
Big green button. Okay. Okay, ID 58, right?
58.
Okay. Yes. Hello, everyone. My name is Yaroslav Wozak, and today we are presenting the topic, the optimizing kernel configurations and convolutional strategies for efficient shallow CNNs in real-time vision systems. So the development of robotics and automated systems often rely on computer vision, and this is a key component to navigate environments. Sometimes, of course, in addition to lasers, ultrasonic gadgets, etc., computer vision is now very important to robotic systems. And normally the convolutional neural network is the best method for image-related tasks, such as classification and object detection or localization. It's very important to design the CNN architecture that balances the accuracy and computational cost, because especially in robotics or edge maybe devices, the computation resources are quite constrained, and we have to balance the computational efficiency and the accuracy of the network. There are very many great networks like ResNet 101 or Inception networks that achieve great accuracy. However, they are very heavy. And on the other hand, there are small CNNs like MobileNet or SqueezeNet. They are lightweight, they're good, but they lack accuracy perhaps sometimes. However, the MobileNet and SqueezeNet are good candidates as, good value DL networks. So computational efficiency depends on different parameters. When talking kernel-wise, they are the size of kernel, the stride and the dilation used with the kernel, etc. Talking about the whole network, the main factors are, of course, the number of layers and the layer or block architectures. For example, the depth-wise separable convolution is a great example of the good, I would say, a block that is quite efficient without losing in accuracy. So we wanna examine how the network, how we can make the detection, the classification more accurate with improved performance, taking into account the high spatial redundancy of the image. For example, blurred images. So what we did, we used simple data sets. That's true. They are quite simple, but they are a good start. The MNIST and the CIFAR-10 datasets. They were chosen because they are small and they allow for quick iterations, so we can create many different networks, many different models in short time. Despite CIFAR-10 and MNIST have approximately the same resolution, MNIST is 28 pixels, CIFAR-10 is 32 pixels images. The CIFAR-10 is much more complex and it has its effect on the accuracy. Across all trainings, we use the two-layered convolutional network with 16 channels in the first layer and 32 channels in the second layer. We use the max pool after each layer. Quite small network. Yeah, I did not mention here that we trained a network for only 10 epochs each because the datasets are quite small and 10 epochs is actually enough. Well, mostly enough. We use the grid search. We vary the kernel sizes from 3x3 to 11x11. And we isolated the kernel variations, meaning first we vary the sizes, then we vary the striding and the dilation. We only use the dilation of 1, which is no dilation, which is normal kernel, and dilation of 2, well, with 1 pixel between each 2 pixels in the kernel. And for strides, the same. We use only 1 and 2 numbers for the strides. Yeah, because for increased strides, since they downsample the image, we remove the pooling layers to preserve the final convolutional layer output. We use the performance metrics, simple performance metrics like top 5 accuracy and average execution time, and we scale the data sets spatially, like we scale them to 64, 128, and 256 each. So, first of all, when we vary the channels, it is known that it's preferable to use the number of channels divisible by 32 because GPU kernels prefer to run threads in groups by 32 normally. So that's why most networks start with the 33 channels, but we started with the 16 channels and vary the first channels in the first and second layers. What we see here is that using the 16 channels in first layer and 32 in second gives the best accuracy at 33% for the CIFAR-10 dataset. For the MNIST dataset, we can see actually here, for the MNIST dataset, it doesn't really match the scale of this dataset. The accuracy is always quite high, so it's not really interesting to look at this dataset. But for the CIFAR-10 dataset, we can see that increasing the number of channels in the first and second layers can increase the accuracy by 7% instantly. However, we continued our research for this configuration. Just because it was a little bit faster for training and inference. However, maybe we should have used this configuration. It brings much better results. Okay, going next. Yeah, again, for MNIST dataset, there is not really nothing interesting. We can see that these are the kernel sizes for the best performance. They were like well, normally we can see that the kernel sizes are quite big. Well, this is because the dataset is quite simple and big kernels can still fetch enough features to provide good accuracy. For CIFAR 10 dataset, we can see that for the small one, which is the original size 32 by 32, the small kernels perform best. And when the spatially the dataset, the images are scaled to 256 by 256, bigger kernels prevail. However, the accuracy drops significantly. So the just simple two-layered CNN is not enough to classify this small dataset. Going further, we assess the dilation, the impact of small dilation and strides. I'm not sure if you can see anything here, but the green ones, this is the original CIFAR 10 dataset, I mean of the original size, and this green dots mean that the best performance is achieved by a simple two-layered network without using any stride or dilation. However, the orange dots depict the 64 by 64 spatial resolution, yeah, and the blue ones are 128 by 128. Here we can see that light orange color is the dilated network. Shows better results here, as well as for 128. It's also shown here that the dilated network has the best results, which means dilated networks with small dilation have better accuracy and good performance on spatially redundant datasets, as we did in our research. Going to conclusion, the Shallow CNN's excellent, simple, low-resolution data, MNIST, achieves 98% constantly, I would say. With its CIFAR 10 dataset, we need to tune the network more. Larger second layer kernel normally allow us to take this, to deal with spatial redundancy. The dilated convolutions benefit high resolution when spatially redundant inputs, as mentioned earlier, 64 by 64 shows us good results there. About strided convolutions alone, they reduce accuracy significantly, and when they are not paired with any other standard filters. Our intuition was that strided convolutions should have performed best because they should be quite fast, because we don't use the max pooling operation, and secondly, they should also better account for spatial redundancy as dilated convolutions do. But this was not seen at all. Strided convolutions can constantly perform worse. And standard convolutions remain best for small, simple inputs, whereas the hybrid strategies suit feature-rich large images. That's it. Thank you very much.
Yes, thank you so much. We have got questions.
I don't hear questions.
Yeah, Gabi, I have only one question. Where you find the kernel for your research? Open source decision or maybe existing decision?
What do you mean? By what? Where do I find the kernel?
This is the software. This is kernel. This is very close software. When you find the kernel, maybe you create own kernel.
Okay, I think I see a question. So first of all, we use the PyTorch as a software, as a library to run our neural networks. And secondly, the kernel size, this is basically the filter size, which is the matrix size that is used to do the convolution operations by the PyTorch library. So these numbers from 3 to 11, they are the most common numbers. Like we all know that 3x3 convolutions, where are they? They are most common because they are small, they are quick, they tend to preserve good fine-grained features across the image. And this, I would say, the smallest filter size that is feasible to extract the features. And the 11 is the maximum number because, well, AlexNet used that and they showed, well, the research is different, showed that 11 by 11 is quite big kernel size, and it, hides a lot of features in later layers. So it's not really good to use such big filters because we cannot extract fine-grained features from an image. But still, we varied from 3 to 11.
Yes, thank you so much. It's very interesting. Thank you so much. The next is.
Thank you.
Next, paper ID 127. Please, can you? Uh, 127. Ibrahim Ikteb. Did you, will you present paper ID 127? So, I think we can continue. Hey, Ibrahim, are you ready?
We cannot hear you. Could you please turn on your microphone? I think it's tech glitch. Maybe we'll start to the next. We cannot hear you.
Okay, Ibrahim, please fix your technical issues. Now we will continue with the paper ID 138.
Hello, everyone.
Hello.
Wait a second.
Ibrahim,
Nice to
can you
meet
stop
you.
sharing your presentation? Okay. So you can start.
Yeah, of course.
Okay, just
Yes.
kind of reminder, we have 7 minutes, okay?
Oh, of course.
Thanks.
Just, wait a minute.
It's okay, you can start.
Oh, okay. Hello, everyone again. Nice to meet you. My name is Yedili, and I'm happy to present our paper. It's like an AI-driven smart digital assistant bot for improving student support service. My team is me, Talsun Shasimbayeva, Madina Mansurova, Baljan Disikova from Al-Farabi Kazakh National University. Okay, let's talk about project. Sorry. In this slide shows why our project matters. At Al-Farabi Kazakh National University, students have troubles finding information quickly. Staff are busy with too many questions, and this slow down work and learning. And our solution, the Al-Farabi chatbot, uses technology like NLP, natural language processing, large language models, and vector database to make find information easy, and reduce staff work and improve study service. The next one slide is here we compare models for our solution, the Al-Farabi chatbot. The tables look at Ollama 3.1 by Kaz-LLM, DeepSeek, GPT-2 version. We checked by size, language support, response quality, deployment options, training, fine-tuning, latency, context window, and situable for student support. And the first one we picked Llama 3.1. It's by Kaz-LLM because he is the best one in the choice. The second slide shows how our solution, the Al-Farabi chatbot, works. A student asks a question, the bot uses a Llama-based model to understand the question, and the next stage, model checks a knowledge base and student information system to find answer. Then it replies quickly. If the question is so hard for model, the staff can help to answer the question to student. This process gives fast, correct answer and save time. The next one is structure. This slide shows the structure of our solution, the Al-Farabi chatbot. The diagram shows a system flow for processing user data. It starts from users and goes through various stages like documents parsing. It's small. Can you repeat?
Could you please increase the size of the features? It's not readable.
It's not readable. Wait a moment. Second. Is this better?
Yeah.
Oh my god. Sorry. Wait. How I can show this diagram?
You make it a little bit small, so it will be seen.
Wait a second. Can I open in another window? I guess it's better.
Okay.
It's okay?
Yeah.
Okay, and again, this slide shows the structure of solution, the Al-Farabi chatbot. The diagram shows a system. Sorry, I had troubles. Yes. The diagram shows again, sorry, a system flow for processing user data. It starts from users and goes through variation stage like document parsing, web interface processing, and embedding, ultimately leading to user feedback and scenario generation. It's like a model generation. It illustration how different components interact in a data processing flow. The next one, it's the next presentation. It's website presentation. These slides show our solution, the Al-Farabi chatbot, on the official Al-Farabi KZ website. The bot is part of the university student service. The design is clear and easy. Easy to navigation. It helps students find answer fast and makes less work for staff. And is the first variation, it's in Russian, and the second presentation, it's in Kazakh languages. The last one, it's the slide shares the results for our solution, the Al-Farabi chatbot. Charts show how many questions it gets and how fast it answers. The bot is 92% accurate, replies in 1.8 seconds, and 85% of students are happy based on surveys. This number shows the bot helps students a lot, I guess. And in the conclusion, our solution, the Alpha-Arabic chatbot, improves students' lives and support at Alpha-Arabic Kazakh National University. It's make to find information more easy and useful. But in the future, we will improve its language skill, like improve in English and Kazakh language skills, and add more university systems. Thank you for your attention. Thank you for your listening. Any question?
I just wanted to ask you the information about, you showed the accuracy of your solution. How did you compare that? How did you calculate the accuracy? What was the reference to your accuracy? Let's say like this.
Can you repeat the question?
So you are showing in the table your accuracy. Yes, 92%. How did you calculate your accuracy? What was the reference for your accuracy? How were you comparing it?
It's like we used statistic of students. We give free. How do you say?
So you ask the students their inquiries were answered correctly. Am I right?
What?
Just ask if the answer was correct. Am I right?
Yes, yes. But it's like how to work. We give in free use to students, and we take feedbacks. After all, we sorry,
That's good. Thank you. Thank you very much.
Was paper ID 127. Where give me step he writes here fixed problems.
Okay, I hope that fixed it. Can you hear me right here?
Okay, but can you turn on your camera, please?
Okay, I've turned on. Yes, okay. Okay, thank you very much. Good afternoon, dear members of the commission. My name is Mikhail Ibrahim. Now I'm going to present the study on restoring coverage in 5G Red Cup networks. This technology has been developed specifically for IoT devices, wearable electronics, and industrial sensors, but has serious coverage limitations. The main problem that the researchers investigated was a significant deterioration in the quality of communication, especially in the upstream channel like PU, SCH, MCH3, and so on and so forth. In urban conditions, the losses reach minus 3.0 decibel at 2.6 gigahertz. This is due to the reduced size of antennas and the simplified design of the RedCap devices. What did you say that 5G reduced capability? It is also known as RedCap in our line. Technology introduced in the version 7, release 17 3GPP. It's designed for low complexity devices like sensors and wearables. Sync device, while this reduces costs and power consumption, it also limits performance, especially in terms of coverage, latency, and uplink reliability. Now, I would like to say about the restoration of the coverage in 5G and Red Cup. This formula used for the the prototype 5G new radio, and the second one, the 5G new standard 5G new RedCap. With a number of parameters, including the budget of the communication line, signal propagation, losses, and antenna efficiency. Yes, you can see it. You can see here receiver power, transmitter power. Yeah, also known this is formula: propagation loss, feeder loss, and the additional losses. The next one is estimated loss of the coverage for RedCap related to the channel bottleneck of reference user equipment, new radio, and important indicator of coverage assessment is a MIL, which is characteristics the maximum allowable signal loss. Yeah, you can see here maximum transmitter power, antenna amplification, and so on and so forth. In the next slide, I would like to say about the about the graph MIL value for one channel, the QHCH. It is I would say, is responsible for it is uplink channel. It's used to carry the uplink share channel. For each simplifier result, you can see here all of these vendors like Samsung, ZTE, Oppo, CAT give their like average value for this channel. You can see here. Yeah. Let me see that. Yeah, how you can see that the best result obtained by the next vendor is FreeTV 151.6 decibel, which indicates the receiver high sensitivity and the better ability to communicate with a weak signal. And most companies, like including ZTE, Oppo, and CAT, Xiaomi, DCM, and so on and so forth, demonstrate the values in the range 142 and 146 decibel, which is the average lowest level. Yeah, the analysis confirms that the signal quality in this channel depends on the manufacturer's technical solutions. Yeah, companies with lower middle values may consider optimize the signal processing algorithms and improve the hardware component. Next, here in the next slide, I would like to say about all channels like PDCCR, how I said before, yeah, MCG2, MCG4, 3, and so on and so forth. Here, all of these vendors give their average, average value for each parameter for each channel. Yes, this allows for better evaluation.
Sorry, you have some troubles with your sound.
I have some trouble with the microphone, with the voice, yes, right?
Now it's okay.
It's okay. Okay, so yeah, here I would like to say about the each vendors gives their average values for each channel. How I said before, this allows for better evaluation and comparison of the overall performance of device in urban environments. Yes, and analysis of the graph of values across channels for different manufacturers showed significant difference in the signal reception and transmission characteristics. Here you can see that here the current loss for the two receiver equipment. Yes, here. The next slide you can see only one receiver for RedCap. We can see that difference here. Just I would like to say about this in this graph showing the average MIL. How is it before? Yeah. In analysis of the graph of values across the channel for different equipments, yeah, you can see. For example, it's for the first channel is 11.4. Here 15.4. 0.4. Yeah, you can see that for two transmitters is more available. Is more, I would say that is more rather than the for one transmitter, one receiver. I would say equipment, yes, here. And here I would like to see the comparative analysis of the coverage loads for RedCap. Here I showed the every channel's parameters in the graph. You can see here in blue it's for one transmitter, one receiver. RedCap is user equipment. The second one is the second. You can see here. This I would like to say that comparative analysis of the coverage loads for different channels for RedCap and so Yeah. When comparing the indicators of the average coverage loss on different channels, yeah, you can see here, yeah, right. So let me just say, yeah, you can see here. In conclusion, I would like to say that these important aspects, restoring coverage when it comes, identifies the main problems and such as possible solutions here. Yeah. Now I would like to say that now the researchers, the manufacturer believes that the current obstacle to RedCap is a lack of devices that support this technology. Yeah, I would say before is a new technology that published in 2022, but now its manufacturer is working on these standards. Yeah, so RedCap can only be implemented in 5G network, which has been seen from various reports. Operators are extremely reluctant to be switched to, and that's what I would like to say here. You can see my references. And so let me just say that all of these numbers, yes, 19 and 15 were taken from the open source. It is what the document.
Ibrahim, we can't hear you.
You can hear me. Can you hear me right?
No, can you like a bit louder, please?
Okay. Can you hear me right now? Because I'm speaking louder.
Okay, now.
Can you hear me?
Yes, it's okay.
Okay. So I was talking about the open source. Yeah, 3GPP. All of this like a database was taken from the open source. It's 3GPP side. And so from this document, just I was doing an analysis to present and to give the comparison of this like new standard. Okay, thank you very much. Okay, I'm okay. I'm finished.
Thank you very much. It was very interesting your presentation. I have just one question for you. I know that this is a big project, and once again, it's coming from China because China, I guess, one of the designer, developer, and owner this type of the technology. So my question to you: do you want to implement in Kazakhstan? If yes, what types of the case study you consider? I mean, the 5G automation, 5G power, for example, consumption. And next question is, do you consider the integration with China, this type of the technology? Because it's one of the most like producer of this suggestion and the ways. Okay, thank you.
Okay, so thank you very much for your question. I would like to say that, this technology is a new standard. Is all of the manufacturer vendors working, like you said, China vendors, like maybe I can say Huawei, ZTE, and so on, China Mobile Telecom, for example, mobile operators, how to implement in real life. And so now I'm studying about this, like the new RedCap. It gives a more valuable like help for my country. Now we are working on in Kazakhstan, like the mobile operators like Beeline, Kcell, and Tele2 is working with the prototype. It is 5G new radio, but what if you use one antenna instead of two antennas? It will be more valuable. Like maybe we can just reduce some like decibels, but for some vendors, like how I said before, let me just say that Putruwell, Nokia, ZTE is giving the good value for this. I can say that if you use the equipment from these vendors, we can just implement. We can just give it more valuable, helpful help for our country. And so I think it's all. Can you hear me? Can you hear me right?
Any questions? No, thanks.
No.
Ibrahim, thanks for your report. Yes, we can continue.
Thank you very much. Thank you very
Yes.
much. Yeah.
Still paper ID number 141, yes? Okay. So please, you have 7 minutes again. Thanks.
Afternoon. I'm Gio Francis, Intermediate. The topic of my presentation is UMISPER. It is a novel, optimized, meta-heuristic driven, energy efficient, cluster-based routing protocol for IoT-enabled wireless sensor networks. The Internet of Things connect devices via the Internet with wireless sensor networks, ensuring efficient data flow and extending network lifespan. While IoT has many applications, challenges like load balancing, energy use, security, and storage persist. Designing IoT-assisted wireless sensor networks with energy economy in mind is pushed, and multi-hop routing and clustering approaches help. To address this issue, an optimized, meta-heuristic, energy-driven, energy-efficient, cluster-based routing is presented this one. The contribution of this paper. An efficient clustering mechanism utilizing the SCSO algorithm is introduced. The clustering strategy is guided by a multi-objective fitness function incorporating key metrics such as intra-cluster distance, inter-cluster distance, energy, node degree, traffic density, and balancing factor. This approach minimizes communication overhead within cluster and ensures even energy distribution among sensor nodes, reducing premature node failure. For routing, the protocol employs the improved slab-SOAP optimization algorithm to identify energy efficient and reliable paths between cluster and the base station. A fitness function designed specifically for routing evaluates parameters like residual energy, transmission distance, and ring reliability to select optimal paths. This routing strategy mitigates packet loss, reduces latency, and enhances data delivery rates across the network. And this is the framework of wireless sensor network route optimization and cluster head selection. Methodology. The UMISPER model uses SAN-CAT-SOAP optimization algorithm technique for an effective clustering process. The fitness function involves energy, node degree, traffic density, inter-cluster distance, intra-cluster distance, and balancing factor. Additionally, the model uses a routing strategy based on improved slab-SOAP optimization. The ISSO technique finds the best route by using a network-based fitness function. The implementation. The proposed method is in the model and executed using Python in an ordinary system having i5 CPU core and 4 GB of RAM. Following table summarizes the details. The sensor area was restricted to 1000 into 1000 meters square. The probability of cluster head selection is 0.1. The number of nodes varies from 1000 to 5000. Initial energy is 0.25 million joules. Size of data packets are restricted to 5000 bits. And the results. The proposed technique was compared with the existing methods such as ALO, SFO, EADCR, DAL, CHS, fuzzy with rare proof optimization, and multi-hop balanced clustering in terms of throughput, aligned node, energy consumption, and network lifetime. So with respect to throughput, the proposed method is just below 1. That is the best method when we compare with the existing methods. In the case of aligned nodes also, the proposed method is showing more in number. For the energy consumption, this 1000 indicates the number of nodes. This is 2000 nodes, 3000, 4000, 5,000. So the proposed techniques show less energy in different cases. And the network lifetime also higher when we compare with other techniques. So that I conclude, the proposed model benefiting from the robust optimization characteristics of SCSO and ISSO ensure superior performance, maximizing network efficiency and prolonging the operational lifetime of wireless internet. A comparative study with the existing routing algorithm further confirms the advantage of the proposed technique in real-world wireless network applications. In future work, the energy efficiency of the proposed method will be further enhanced by incorporating conversion and data aggregation techniques at the cluster head level, as well as exploring more advanced sound intelligence methods to adapt to more complex and dynamic wireless network environments. That's it. These are the references. Thank you.
Question. What kind of projects do you use to validate that?
Small power. Secondly, yeah, electricity, because nodes have very less electricity. That's the second is range of the network. Usually, this is going to be implemented in a field, agricultural field or somewhere to get sensor range. These are the main concerns.
Can continue with ID 144.
So yeah, today's topic I would like to talk about the integrated AI-based monitoring system for microgrid growth in our vertical farm. My name is Bono Shakir and I represent Astana University with help of founders. So I'll quickly go over the background and motivation of this research, as well as the research objectives, the methodology that we have used, results, discussions, and so the background, why vertical farm and why we are growing microgrids. So as you know, the vertical farming is the concept which is not like recent, but it's really helpful in urban and like big cities when we have when we can use a small area of land, start the stacked layers, to grow any kind of plants. So it maximizes the yield per square meter. It's totally controlled environment, so meaning that we can control the water consumption, energy consumption. Next is why microgrids, because we target it as a crop. It is highly nutritious, and it can be used to healthy product, and its cultivation cycle is very short. So now here comes the big challenge, like how we can control the height, because once it gets like as usual plant, it loses its amino acids and other beneficial components. So that's why we have to control the growth of these microgrids. And we come up with a solution like to monitor this using the video camera and basically detect the microgrids in scale. Nowadays, the research gap is that nowadays we go to our vertical farm, we go every day and we measure the height manually. So this is like a labor intensive and error prone. The existing solutions like light detection, depth cameras are so we need to have some low-cost, scalable, image-based system that delivers accurate real-time data estimates. These are, by the way, real images of our. So here we have. We wanted to validate this use case, and we took all the images of our. Here you can see the Basil microgrid. Wanted to collect first all the data set. So we get around 60 high resolution images with different multiple angles and lighting variations. We have implemented the data augmentation, so it became around 600 training samples. We have annotated those images using open source Label Studio. Moreover, we identify the height of this object. We wanted to integrate a reference object. So we put here as a reference object the coin, Kazakhstani 150 yen, because we know the coin size precisely is 2 centimeters. That's why we use it as a reference object. For our model, there is a YOLO version 11. We fine-tuned on our custom data set. And here our measurements. So in order to find the height, we converted the pixels to the centimeters. At the end, we have validated our results with our phenology journal that we write every day. So it was pretty accurate. These are the evaluation metrics. Precision is very high. Of course, we acknowledge here that there might be some overfitting due to the lack of the large data sets to train. Also, we didn't compare with other models to see, but we take it as a feature work. So there is almost no false positive result. And the mean average precision also is very around 99%. So our result is our measurements show that they are pretty accurate. There is a ±2 millimeter differences. It's the real use case. So as you can see here, the model detects that it's a microgrid. It finds the reference object, our coin, and it compares based on this size, the size of the height of the microgrid. But here we have also another challenge that the angle of camera can be different. So this image, this particular object can be very higher than this one. Actually, they are same based on how you see the object. We take it also as a picture work to focus. Real-time inference. Also, the labor saving. Don't want to go every day to check the date, the rover, and on the yeah. So we have to think about camera placement, standardization. Also, how to use either use edge devices for cloud computing, cloud services. The integration part. Currently, we are sending all the data from IoT devices over HTTP protocol, and we put some others when data reaches the hardest. This is our dashboard that we have constructed. So you see, we can monitor our robots with high performance system. So as a conclusion, This solution demonstrated low-cost AI vision system for microwave height monitoring, achieved near perfect detection, substantive error. This framework can be easily extended to other solutions over the steps. Good prediction, how it will perform closed loop back control. These are the next steps for us. Thank you very much. Do you have any questions? My question is for what you can also say using the solar, for example, use it as direction. Exactly. So when we started this research, I had coin in my pocket. So you were thinking about what to put as a reference object. So just like extract this coin. But of course, the coin would not be defined reference object. Doesn't fit in the vertical plan, especially Kazakhstan. So we will put some ruler, and that would be our reference plan. Yeah, for the quality, because we have also different kind of microgrids. They have different kind of colors as well. Red, I'm going to capture all of this. Thank you.
One small questions. What software do you use in this project?
So it's all implemented in Python. We use Python as a programming language. And also, we have tried to construct our dashboard using library of Python strictly. But we have our custom dashboard, which is based on the JavaScript. Use our local server.
Our next idea 154, Yetki Mohammed. Let's continue with ID number 156. Danila Zepunov and Victor Morozov. Please, can you start your report, your presentation?
Yes, can you hear me?
Here, please don't forget about time limit of 7 minutes.
Okay. 1 second, I'll share the screen. Yes. Can you see the screen? Yeah.
Yes, can start.
I'll start the timer. 1 second. To not lose a track of time. Yeah. Hi everyone. My name is Daniel Zokunov, and I'm with Victor Morozov presenting you work on development of the model for calculating the training speed of intelligent system based on the deep learning algorithms. The rapid evolution of artificial intelligence has intensified the demand of a faster and more efficient training of the deep learning models. So I use the Stable Diffusion to test the speed of training. As of training, I'm specifically referring to a fine-tuning of a model of a Stable Diffusion base XL 2.0 with about 100 images. So let's start. The objective of this research is to develop a valid model for calculating and optimizing the training speed of intelligent system based on deep learning, with the focus on the influence of the GPU hardware characteristics. The goal is to create information system that enables users to make informed decisions about hardware selections, balancing training time, cost, and model performance. Task was to study GPU characteristics. I've specifically used in my work the number of cores of a GPU and the memory size, because they are the most, they have the most impact on the training time, and they are correlated with the cost of a GPU. Then collect the data. The data collected was open source data from the hardware specifications of the GPUs. Then develop a model to try to see a correlation between those metrics, validate the model through a simulation, and used GPU that I had. So all the GPUs that I've used, we can, on the graph, we can see a model of a GPU of NVIDIA, and they're an SRP on the start of the sale. And then we tried to make some constraints on the models, like maximizing the training time. Then we made constraints on some time of the training, that it should not exceed a maximum time that someone wants. Then cost constraints, that the total cost of training the model and all the datasets should not exceed budget. And performance constraints were the performance of the model on each dataset must be at least as good a specified minimum. As a specified minimum, I'm referring to, again, Stable Diffusion based Excel 2.0. So accuracy of the model and like a performance was made. I made the decisions based on the visual observations, because there's no any other way to test Stable Diffusion generating images quality. So then we made a performance criteria defined on, it is defined by the performance of the model on a specific data set on a specific GPU, and the cost of training model, and the time that it needs to train a model. I've had data for 3 GPUs. It was 3060, 3080, and 3090. Then I've tried to describe like a level of influence of every hardware characteristic of a GPU and the impact on training speed, which resulted in a coefficient that calculated for all GPU series. Then now we can see a graph of a model training time that was estimated by using this coefficient that was calculated earlier. We have created a table that can represent the cost of 1 hour training and the training hours needed to fine-tune a specific model. So users can make weighted decisions on what exactly to buy and how long is it going to take, even if they don't have any data on their hands. So then we plotted a graph of an SRP to cost per hour to choose the best one of them all, and the 4070 is the best price per hour efficiency. For higher memory needs, we have a 4080 and 3090 at the moment were optimal choices to go with. So, and our analysis showed that while newer GPUs are often faster in training, the price to performance ratio, it doesn't always scale linearly. And this reinforced the need for a calculation approach of a hardware selection rather than just choosing a newest model. For a summary and our conclusion, I can say that our work showed that deep learning training can be made significantly more cost effective and faster by carefully selecting hardware based on factors of the hardware and the model you need to train, and it benefits the wide range of users. If in future work we aim to expand the model to include mixed precision training and advanced optimization framework like DeepSpeed or FSDP, which can drastically reduce memory usage and accelerate training on limited hardware, which is the key to cost optimizing training time of the models. So yes, that's it for me. Thank you very much for listening. If you have any questions, happy to answer.
So, any questions?
Can you repeat? I didn't.
Any question? No?
Just one.
Okay, one question.
Just one question. Very interesting. Thank you very much. Secondly, my question is, so you proposed the digitization of the training system. Will you, in future, for example, I mean about the practical technique. So do you have time to implement some the practice case study, or it's just theoretical development of the knowledge and increasing and so on? So do you have some practical techniques, and do you want to implement in future with digitization, maybe for some training courses, training platforms, and so on? Thank you.
So if I understand right, does it have any practical use in future? Yeah? Did I get it right? Yes?
Yes, yes. Yeah, yes.
Yeah. Yes, I think it has for like it's not as practical for companies that had like infinite budget, like OpenAI, Meta, and so on. It more focused on the people that don't have that much resources, so we can optimize their spending, and so they can consider spending money in most efficient way by buying the hardware that can get the job done in the time that they need, and not spend like $600,000 for one model, which not every startup can accommodate that much money to spend on the model. So yes, I think we can use it in that in future.
Okay, thank you for your answer, Daniel. So next, ID number 159.
Good afternoon to all conference participants. My name is Olesya Romanenko, and thank you for the opportunity to participate in this scientific event. I am presenting to your attention a report on the topic. Now I share my presentation. Are you seeing?
Yes, yes.
Presentation.
Yeah.
I'm presenting to your attention a report on the topic digital transformation of the Ukrainian construction industry, current challenges and prospects for utilizing global experience. From a team of authors, Olesya Romanenko, Lyudmila Levergyan, Olga Yudicheva, from Kyiv National University of Construction and Architecture from Ukraine. Just a second. The purpose of our research is to study the problems and prospects of using global experience in the digitalization of the construction industry in Ukraine. Subject of research analyzing the current state and prospects of digital transformation in the construction industry of Ukraine in the context of global trends. In the figure 1, you can see model of digital transformation in the construction, which consists three stages. First, digitization, next, digitalization, and third stage, digital transformation. Digitization is the process of converting all construction processes into a digital format. Digitalization of the construction industry means the introduction of digital technologies and tools to improve the processes of design, construction, and operation of buildings and structures. Digital transformation is the result of implementing digital technologies leading to transformative changes. Key aspects of digitalization in the construction industry include building information modeling, Internet of Things and sensors, artificial intelligence and data analytics, automation and robotics, cloud computing and mobile solutions, augmented reality and virtual reality, digital twins, drones and unmanned aerial vehicles, and 3D printing. To assess the state of digitalization of Ukraine and its construction industry in particular, a comparative analysis of the future of the network economy of countries was conducted using the Network Readiness Index 2024, which is a comprehensive assessment of indicators such as technology, people, governments, and impact. According to the NRI 2024 report, the United States, Singapore, Finland, Sweden, and the Republic of Korea are among the most network-ready societies in the world. Unfortunately, Ukraine lags behind developed countries in all indicators of network readiness, ranking 43rd in 2024. The lowest indicator concerns technology, which negatively affects the overall level of digital transformation of the country as a whole and the construction industry in particular. The low digitalization of Ukraine's construction industry stems from, first, technological backwardness and weak digital infrastructure. Most domestic firms, especially SMEs, lack sufficient digital infrastructure, relying on traditional methods. BIM adoption, crucial for AI, is low and limited to specific projects and international companies. Second factor, insufficient investment in innovation, limited R&D investment due to macroeconomic instability and geopolitical risk prioritize short-term survival over long-term innovation. Third factor, staff shortage and lack of specialized skills. A significant lack of the professionals with combined construction and IT knowledge, inadequate digital literacy, and limited access to training hinder AI implementation. And fourth factor, uncertain regulatory framework. The absence of clear BIM and AI regulations, including standards for digital modeling and data management, and unclear responsibility for AI-driven decisions further impacts innovations. To accelerate the digital transformation of Ukraine's construction industry, we have developed a roadmap for the digital transformation on the construction, which includes three phases. Phase one requires the implementation of the following measures, such as analysis of the state of digital transformation in the construction industry, development and approval of a strategy for the digitalization of the construction industry, updating the regulatory and legal framework regarding the implementation of BIM and other digital technologies, creation of digital platforms for information exchange and collaboration. Next, second phase includes such implementation of BIM and pilot construction products, development of the digital infrastructure, the construction industry, cooperation with international development companies, training and certification of construction industry specialists in BIM and other digital technologies, attracting investments in digital technology, including foreign ones. And third phase include large-scale implementation of BIM in all construction projects, development of digital platforms for managing the life cycle of construction facilities, implementation of artificial intelligence and machine learning technologies in the construction industry, ensuring the sustainable development of the construction industry through digital technologies. In recent years, the application of artificial intelligence in all spheres of life has become increasingly important. Therefore, we propose integrating artificial intelligence in the business processes of the construction industries, such as design and modeling, costing automation, defect detection, logistic optimization, timeline forecasting, and occupational safety improvement. In summarizing the report, we would like to emphasize the following conclusions. First, digitalization is a key global trend in the development of the economy and the construction industry in particular. Second, the study of the international experience of leading countries such as USA, Finland, Singapore, Denmark showed that the successful digitalization of the construction industry is based on government support, investment in technology, and intersectoral cooperation. Third, despite Ukraine's first steps in the implementation of digital tools such as Unified State Electronic System in construction and the fragmented use of BIM, digital twins, IoT, robotics, AR, VR, and 3D printing, there are significant barriers to large-scale digitalization. Fourth, the proposed roadmap for 2025-2030 is the first step towards the systematic implementation of digital technologies at all stages of the life cycle of construction objects, which will contribute to increasing the efficiency, transparency, and sustainability of the industry. Thanks for attention. I'm waiting our questions if you have.
My name is Lalita, and my question is, we saw a roadmap. Do you have some collaboration with the companies or maybe with the ministry? Do you start to practical implementation your steps?
Yes. To implement this roadmap, it is impossible to have cooperation different spheres as government, as universities, as companies. That's why in Kyiv National University of Building Architecture and Construction, we began implement BIM technology in student programs, our student programs. Also, we have communication with government, with different investment foreign funds, with building companies. We change information which each other and make plans for digital transformation of construction industry.
Thank you for your presentation.
Thank
Any
you.
questions, colleagues? No? So let's continue with the paper ID number 165.
Hello, yeah.
Thank you.
Do you hear me well?
Can you share your screen, please?
Okay, let me share my screen. Okay, do you see my screen?
Yes.
Okay. Hello everyone, my name is Adil Maidanov, and today I want to present our work which named Optimized UAV Control, evaluating SMC and SMC-based backstepping strategies. Other authors' names like Professor Sabirjan Atanov and Hüseyin Canbulat from Ankara Yıldırım Beyazıt University from Turkey, and I'm presenting Gumilov Eurasian National University. The abstract, this paper presents a comparative analysis of slide mode control SMC and SMC-based backstepping control for a quadrotor unmanned aerial vehicle UAV. The study evaluates both methods in terms of robustness, efficiency, and trajectory tracking under dynamic challenges and model uncertainties. After introducing the principle of each control strategy, simulations are conducted across various scenarios. So the results show that the integrated SMC-based backstepping control outperforms conventional SMC, reducing roll angle error by 85%, improve altitude tracking by 66.7%, and decreasing XY axis errors by 60%. So the presentation outlined the introduction, materials and methods, experimental results, discussion, and conclusion. So for the introduction, I can say that technological advancements have increased UAV applications across diverse fields. However, ensuring robust control under turbulence and model uncertainties remains challenging. So the sliding mode control, SMC, and backstepping methods offer promising solutions. The integration enhances stability, trajectory tracking, and adaptability, making them effective for complex quadrotor UAV dynamics and environments. So shortly, UAVs increasingly used in many sectors. We have some challenges like dynamic environments, wind, under actuation. So SMC and backstepping control are popular for robustness and accuracy. What are control strategies? So slide mode control maintains trajectory under disturbances. Backstepping control, recursive control low for better stability. And SMC, the hybrid control SMC with the backstepping control, combines strengths of both methods. For the dynamic modeling, it was based on Newton-Euler equations, includes drag, gyroscopy effects, and aerodynamic torques, and state space representation for simulation. The simulations for the simulation, it was used MATLAB and Simulink. And there were 3 scenarios. So first scenario, ideal conditions, which means ideal flight, like with any disturbances or interruptions. Second scenario is external disturbances, like as gusts of wind introduced in order to test the capability of each controller to retain stability. And third scenario, like model uncertainties, if we have some aerodynamic variations like inertia or something like that, it was necessary to add that model of uncertainties in order to assess the robustness of the controllers. So here you can see that the 3D position and orientation trajectories. This one for the XYZ axis. This is roll pitch yaw. So you can see the graph. Shortly, I can say that the roll, which means axis of the rotation from front to back, pitch means side to side, and yaw, it's rotation from the top to bottom, and pitch means side to side, like if we imagine that a nose of the plane goes up and down, and yaw, it means turn to left to right. And the next graph, we can see that position tracking performance of each controller with the SMC backstepping UAV, like it's actual, and it was desired, like we can see that with the red dots line, and tracking errors for each axis. The next one, it's orientation tracking performance. Same thing. You can see the graphs. Shortly, you can see the result from here. Experimental results, we can see the improvement by 60% for the x-axis tracking error, and we see that the improvement by 85% in the roll angle error, like I said in the beginning. So for the discussion, I consider future work should focus on lightweight implementations, but by light implementation, I can say it's for the reducing energy, memory, and stuff like that, and validation in real conditions to ensure practical deployment of the hybrid control strategy. In conclusion, shortlist this hybrid SMC BS effective for robust UAV control. It is recommended for high demand dynamic environments, and the future work, it can be used for real-time tests, sensor actuator effects. Here you can see some references for this research. And thank you for your attention. If you have any questions, so you can ask, please.
One question about did you have some limits of your research experiments? And about future work, I read that you planning real test experiments. And do you have some currently? Maybe you have the UAV. Maybe you can say what equipment you have currently, or
Yes.
just want to buy in future. Maybe you don't have any.
Yes, thank you for your question. So yeah, we have equipment. So we this is like one of the part of my dissertation work. So and we ordered from China actually some quadrotors. In previous works, we also use some drones. So yeah, so for the real-time tests, so we will use, yeah, and we will test like for the practical implementation, yeah. And for the limits, I can say like we have no limits because it's like simulation. We can use aerodynamical block in Simulink and just add that and use like that for the modeling and simulation. Thank you.
Thank you, so let's continue. Next paper, ID number 177. But I think we did have authors of these papers, so we can continue with the paper ID number 195.
Hi, yes, I'm here. Hi, let me share just my screen.
Okay, so you will be given 7 minutes, please.
Okay. Hi, it's my pleasure to be with you. I'm Razan Al Haris. I'm going to present our work, which our paper name Anomaly Detection in IoT Healthcare Security using Machine Learning Methods. We are going to speak about introduction, our problem statement, and the objectives of our paper. Then we are going through the results and discussion, and finally to the conclusion and future work. To start, as introduction, as we know, IoT is a fundamental technology in the domains like smart manufacturing, transportation, and healthcare. It's connected people, devices, and environments through sensors network, collecting real-time data that transmit to the cloud. This data supports more efficient system management and enables AI-driven automation. In essence, IoT invention a fully connected world where everyday objects have internet access. For the problem statement, as IoT continues to expand in the healthcare, the security of these interconnected systems become increasingly crucial. IoT healthcare devices, while enhancing patient monitoring and care, are vulnerable to the various cyber attacks, including data injection, spoofing, and man-in-the-middle attack. The traditional security method often fail to address the unique challenge posed by the scale and complexity of IoT network. Therefore, there is a pressing need for effective anomaly detection mechanisms that can accurately identify threats in real time, ensuring both privacy and patient data integrity of the health system. So our research mainly aims to evaluate the efficiency of supervised machine learning models in detecting IoT-based cyber attack, with a focus on identifying the most robust and reliable approach for real-time security in healthcare of IoT environment. Our objective, first, to examine the key security challenge in IoT health system and emphasize the need of robust threat detection. Secondly, to evaluate four machine learning modules, which they are support vector machine, naive Bayes, random forest, and logistic regression for the threat detection in IoT environments. The third, to identify the most effective model for real-time IoT security, highlighting that random forest has a high accuracy and low misclassification rate. To evaluate and measure the models, recognizing their balanced performance on detecting the IoT system. For the methodology, first we used Orange, and our methodology is going to be in the first phase, acquisition of the data, then pre-processing the data to guarantee when we are going to use it is going to be the full data, clean, and all the features we are going to select it to be better. Then splitting the data to training and testing data sets, which we use here like a fixed portion, which is 70% for the training, 30% for the testing. Then we select the four models, as I said. Then after that, performing the measures and comparison the result of the four machine learning models that we used. For the data set, we used a data set from Enhanced Healthcare Monitoring System, designed especially for Internet Medical Thing, cybersecurity research. This testbed provides a comprehensive dataset by collecting both the network flow statistics and the patient biometric data. It comprises mainly four components: the medical sensors, the gateway, the network, and control the system visualization capacity. Mainly, this patient data is collected through sensors and sent to the gateway, which then transmits the data over the network to the central server. For the statistical, the number of the normal samples was 14,272, and for the attack samples, it's 2,046. In total, it was 16,318. For the attack, usually we know there is two different attacks usually happen: spoofing, malware injection, and DDoS. So for our data, for the category, it was for here the normal data, as we said, it has much, and for all the attacks, the percentage is low. For the category itself, this showing the normal, and for the attacks, there are two types of them: the spoofing and data alteration. For the machine learning that we use, we apply the supervised learning technique, which they are the naive Bayes, random forest, logistic regression, support vector machine, to understand and to make like a deep comprehensive study for this supervised learning technique, to understand them and to see how they are affecting on understanding this IoT security environment. For the results and discussion, The evaluation results highlight the effectiveness of different machine learning models in detecting IoT-based attack. Random Forest achieves perfect score across all evaluation matrices, which they are OUC, classification accuracy, F1 score, precision, and recall, demonstrating exponential properties in handling complex data patterns. Naive Bayes and support vector machine also performed remarkably well with the near perfect accuracy and F1 score, along with the high AUC values, indicating their strong capacity in accurately detecting the threat while minimizing the error. And here we see Random Forest got the highest degree regarding to the others. These are the confusion matrix with the actual values and the predicted values for the four machine learning models. For future work, what we are thinking to plan in the future, first implementing real-time anomaly detection on live IoT health scale system to evaluate particular aplicity, explore deep learning techniques such as CNN, LSTMs for capturing complex patterns in biometric and network data. Optimize model for edge deployment to enable efficient threat detection on low resources IoT devices. Integrating explainable artificial intelligence to make detection results more transparent and to make it interpretable for healthcare professionals. For a conclusion, machine learning model shows varying effectiveness in securing IoT system with performing depending on the algorithm used. Selecting the right model is crucial as it impacts accuracy, detection rates, and the ability to minimize the false alarm. The results underscore the crucial importance of model selection in IoT security, with the Random Forest emerging as the most effective approach. Future research could explore hybrid models or alternative algorithms to enhance performance under evolving attack scenarios. Machine learning holds strong potential for enhancing IoT security, and continued research is needed to develop more adaptive and robust solutions. That's all, and thanks a lot for giving me opportunity to be with you.
Thank you.
No. Thank you for the presentation. I have a quick question regarding, so apart from the IoT security, how do you handle the data governance regulations for the sensitive data like patients?
Pardon, your question isn't clear. Can you say it again?
Yeah, so apart from the IoT security, you mentioned that you have a data set collected for the regarding the healthcare patients data. So how do you handle? Do you apply some regulations, data governance, or
Okay. Now for the data, it's a public data set that we can just reach it, download it, and use it. But if we want to improve this thing and to handle it for the IoT governance, definitely they will have regulations, so we need to follow. But for a meanwhile, just it's a publicity and we can collect it and gain it easily.
Okay.
Thanks.
Okay. Thank you. Next presentation.
We already with 424. Daud Sarıkan, Devlet Organizasyonu, Speaker number ID 424. Is it online or offline?
Online.
Can you see my screen? Or
Yes, we can hear and see. Can you share your screen, please?
Yes. Mhm. So, can you see my screen again? So, hi everyone. My name is Yerdal Turihan, and I'm currently a student and a researcher at Kazakh British Technical University, which is located in Almaty, Kazakhstan. Today, I'm really honored to present the results of our research conducted in collaboration with my colleagues Nurdaulet Altınbekov and Pakizar Shimai, titled Aesthetic Index for Art Paintings Using Visual Features. So let's begin with the context. In today's digital world, images are everywhere, from social media feeds to e-commerce platform. The ability to assess the image aesthetic quality of these images plays a really crucial, vital role in many applications, such as image ranking, content recommendation, and etc. However, aesthetic evaluation task is not a really straightforward task. Beauty is really subjective, and it varies depending on culture and emotion, personal background, and the context. Despite the subjectivity, the researchers have long sought ways to capture the algorithms in order to evaluate the aesthetics of
Sorry for interrupting. Your slides not moving.
Oh, okay. Can I start again?
Yes. Do you change your slide or not? Because we have we see just the first page of your presentation.
Oh, you see only the first page?
Yes.
Oh, it's not changing, right? Okay. Can you see it or not? Can you see it? Yes? Oh, okay. Okay. While traditional methods rely heavily on objective image metrics or algorithms or rule-based systems and etc., they often fail to grasp the nuanced features, as I mentioned before, like emotional or cultural backgrounds and etc. And our goal was to explore a more intuitive and feature-based approach. So, let's go through the objectives of our study. The first of all was to develop a computational framework that can evaluate the aesthetic quality of image and define and extract key features from the image, symmetry, simplicity, and color harmony, and to apply this framework to a large-scale data set, and in order to compare the aesthetic index with other paintings. And finally, to identify limitations and the future directions of our work. So first of all, we may start.
Sorry, again, the problem slide changing right now. We can share your presentation if there are some problems.
Oh.
Okay. That's уже все, не только, но и интернет тоже. Okay,
Can you see it?
Okay, just a second and we will share your presentation and you can continue.
Okay.
Okay. Can you continue your presentation, please?
Okay.
So what
Can you see it? No? Yes? Oh, okay. Okay. For our analysis, we used a well-known data set with named Best Artwork of All Time. Here you can see the sample image from it. And this data set contains thousands of high-quality images from the famous painters. And it offers a rich and diverse foundation to our analysis. Let's go through our methodology. First of all, we started identifying three essential visual features: symmetry, simplicity, and color harmony. Each image was processed and analyzed using image processing techniques to quantify these features. And here's the simplified version of our pipeline. The image is loaded, features are extracted, and the values are normalized. And the final score is needed for evaluating our analysis. Next one. As you can see, I hope you can see, we can go deep to each feature. For the symmetry, we calculated the vertical and horizontal symmetry, initially dividing the image into 16 parts. And taking the dominant color from each part, we evaluating the symmetry score using Euclidean distance. The next one is the simplicity. Simplicity is evaluating using K-nearest algorithm, edge detection algorithm, and calculating the contour. The color harmony was accessed by checking if dominant colors aligned with known, famous color harmony schemes, like complementary, analogous, and the split complementary. We used three types of harmony in our research. Okay, the next one. Here we can go through our results. Here are the top 10 paintings based on our aesthetic index. While the results are somewhat subjective, we found a correlation between high scores and the artworks that often praised for the visual balance and the beauty. The next one is across the data set, the mean score, average aesthetic score of images is 71.74. And this gives us a general baseline for aesthetic composition in classical artworks. And here we can see in the table the average aesthetic score for authors. And this is the top 10 authors with the most average aesthetic scores for their paintings. And the next one, I made a showcase on a random painting that I did myself. Here, as you can see, the harmony count is 1. Simplicity is equals to 53.56, and the symmetry is the max value from vertical symmetry and horizontal symmetry, which is 0.942, and the overall aesthetic score is 60.36, which means that the average aesthetic score is 71.74, and the random photo, random image is not showing the good aesthetic score. So in conclusion, we can say we presented the computational framework that offers a simplified yet effective method to approximate how humans perceive beauty in paintings. While approach captures basic visual features like symmetry and color harmony, it does not account the deeper emotional factor, psychological factor, or historical factor, and etc. that can be really influence the aesthetic judgment. And in the future, we hope to expand this model by including other features like colorfulness, lightness, and making apply this method to the other types of media, like digital art or graphic design. Like in our case, we made the case in art. So I hope we can change it to the photography, digital arts, making it more human persistent. And I don't know, like integrating machine learning or even neural networks, so it can it can fit, by the way. So as you can see, this is the references. And finally, I want to thank you, my co-authors, our university, and the conference committee for the opportunity to share this work. Thank you for your attention. I'll be happy to take any questions, and you can ask it. Thank you.
Thank you for your presentation. I have a question about the results. We saw the top authors who had the average score, yeah? 10,
Yes.
I think. And it's just, for me, it's interesting who had the more high score from art authors and who had maybe, as example, the lower results.
Yeah, like the highest value here, we have the Paul Gonin. Like its average aesthetic score is 76.3. Through its total artworks number is 311. Like our method is not showing the real aesthetics, it's subjective, and we really know about this. And this is the average aesthetic score for every author, for every picture, for every image, I don't know, according to our method. And it can be shown well, like here. So I hope I answered your question. If you want to ask another.
And in your opinion, are you agree with this index or no? Where you saw the paper?
Oh, that's a great question, by the way, because I agree. I agree if there is not if there was other results, I would definitely agree, because I use the dataset best artworks of all time, which means that all artworks here is aesthetically by default. Like, but I really love it. It fits. Like, I really love minimalistic images, so I agree with this. Yeah. So that's all.
Thank you so much.
Thank you too.
The next presentation is next. Nazra Krukova, ID 450, please.
Yes, I'm here. Can you see me?
So, can you share your screen? Yes, Nazra Krukova. Okay.
Sorry. Okay. Do you see my screen?
Yes, yes.
Okay, let's start. Good day, everyone. My name is Dilnazra Kslikova, and today I'm presenting the paper titled Implementation of Continuous Signal Preprocessing Methods for Segmentation in collaboration with our colleagues from University of Technology Malaysia, Aston IT University, and Istanbul Technical University. Okay, let's start from the introduction part. As we all know, signal segmentation is really crucial in domains like medical imaging, video surveillance, autonomous driving, and so on and so forth. However, the raw input signal data often contains like noise or other distortions that may lead to bad image segmentation, bad quality of image segmentation. That is why pre-processing methods are really important in order to improve the segmentation. The research objectives of this work are to develop and evaluate continuous signal preprocessing methods to enhance segmentation and also implement an access for the segmentation unit-based model using Pascal-Vogt 2012 dataset. Let's talk about the background. Besides the preprocessing method that we used in this work, there are a lot of common filtering methods such as Gaussian, median, Wiener filters, and also nowadays a lot of people use like machine learning methods like clustering filters or autoencoders. Also, I want to mention that noise often arises from sensor limitations or environmental conditions. For this work, we used contrast-limited adaptive histogram equalization in order to enhance the image contrast and detect the edge boundaries. Also, we did normalize pixel values of images and masks from 0 to 1 range, and also used the data augmentation to improve model robustness, such as shiftness and other. For the segmentation, we used UNet model, which is really widely used model nowadays because of its simplicity. Basically, it uses encoder and decoder structure with skip connections to retain spatial information. Encoder is used for convolutional layers, followed by max pooling for feature extraction, and decoder used for upsampling layers connected to encoder outputs for precise reconstructions. For the dataset, we used like widely well-known Pascal-Vogt 2012 dataset. It consists of 11,530 images with different 21 object classes and object sizes. For the training details, we use such key functions as dice coefficient, dice loss, and for the loss function, combined binary process entropy and dice loss for optimizer Adam, and also we trained the model with 150 epochs in batch size 8. Now, let's talk about the results and discussions. We can basically divide these results into two parts: complex images and easy images. So basically, we can see here input image, true mask, how it should be, and the predicted mask of our model. The first figure, we see first example, and as you can see, there is really that predicted mask with no edge boundaries and with no good contrast. And let's look at another one. Here we see that at least we can see the computer here, but it's not like the true mask. The next one is also, you see the human bike input image. It's really noisy, true mask and predicted mask. Here, at least we can see edge boundaries, but still it doesn't look like the true mask. Now let's look at the easy images. It's basically one photo, one image, and I can see 4 results here. Sorry. First of all, again, input image, true mask, and predicted mask. Next one. And here we can see also noisy input image, but the predicted mask is a little better than the previous one. Here it also looks better, but the last result, we can see that it almost looks like the true mask. We can see edge boundaries, good contrast. That's why I think that this result is better. Next one, we can see the table, which consists of comparison between figures 2, 3, 4, and 5. Here we see that input image is almost the same, but in figure 3, it's an airplane in the background enhanced with Kalahi, the preprocessing method. But the figure 5 was better than previous figures, but it still has errors in highlighting the aircraft's outline. So let's look at the model performance. Here we see 3 metrics such as accuracy, dice coefficient, and loss. We see training and validation, but even though training and validation accuracy is good enough, like 72.38%, dice coefficient is really low. I think it is because we are like comparing true mask and predicted mask and implying on each other. That is why dice coefficient is a little bit low. So to conclude our work, I want to say that a lot of further improvements needed in data size, architecture, hyperparameters, and post-processing. And also we can change the destination from the image to the video in order to do it in real time. Yeah, basically that's it. Thank you for your attention. You can ask questions.
Thank you.
Thank you.
You mentioned in your report that you use net model, yes? Can you explain your choice? Why did you use this model?
Because this model is well-established architecture for image segmentation, and it provides good balance between performance and implementation complexity. It is really simple, and the architecture of this model with skip connections allows for effective spatial feature preservation. But also I want to mention that our goal is to pre-process, not to compare the segmentation methods. That is why we want to use like simple model, and the UNet model was really perfect and suitable for this purpose.
Okay, but you didn't compare it with others?
No, we did not compare the models like in this work, but we did compare the pre-processing methods, not model simulation models.
Okay, thank you then.
Okay, yeah. Thank you.
Okay, and the last one, yes, paper ID number 219. Sorry for your waiting.
The last
Hi everyone, just a second.
the last presentation.
Yeah. Okay, just. Can you see my presentation now? Oh, just.
Can you switch on the presentation mode, please?
Just a second.
Okay, we can share your presentation if you don't mind.
Yeah, please. Thanks. Well, thank you. So greetings to all present. I'm Serhii Topolov, a first-year PhD student at the Kyiv National University of Construction and Architecture, and I would also like to introduce the co-authors of the research, namely Tatiana Honcharenko, Ilya Sachenko, Igor Rachkasov, Anatoly Fisan, and Sergei Pely. We are glad to present you a report on automated face recognition system using convolutional neural networks. The relevance of this research stems from the growing need for facial recognition in security, identity verification, access control, and other. The object is facial recognition system using deep learning and convolutional neural networks. The subject focuses on models for image preprocessing, feature extraction, and classification. Go to the next slide. Our system follows a comprehensive approach with training and testing phases. In preprocessing, we implement contrast-limited adaptive histogram equalization, clash with dual gamma correction for balanced enhancement. We used local gamma correction for non-uniform lighting, and difference of Gaussian filtering, DOG. In stage of phase detection employs cascade classifiers and support vector machine and boosting methods like this. In Lightman uses adaptive affine transform, and while feature extraction, we used combines geometric descriptors and adaptive local binary patterns like LBP. And the next stage, training incorporates data augmentations and combined loss function with testing using KNN algorithms. Go to the next slide. Our CNN architecture forms the system core with input image spacing throws multiple convolutional and pooling layers, and convolutional operations apply kernels to produce future maps capturing increasingly complex patterns. And the architecture includes future learning components and structural classifications, and culminating in fully connected layers and softmax output. Go to the next slide. In histogram equalization enhances image contrast by redistributing intensity values. The original purely lit images have facial feature difficult to discern, while after equalization, visibility significantly improves. This makes underexposed regions more visible, crucial for recognition in pure lighting. In the next slide, we implemented Clash to overcome limitations of standard histogram equalization, and Clash operates on small image regions, enhancing local contrast while preventing noise simplification. The process involves block formation, histogram creation, redistribution, equalization, and the next bilinear interpolation to eliminate artificial boundaries. Go to the next slide. For future extraction, we employed the local binary pattern LBP methods to capture texture information, and LBP analyzes relationships between neighbor pixels and their neighbors, creating binary code based on intensity differences. We used R equal 2 and P equal 8 configuration for optimal extraction, and LBP's invariance to monotonic lighting changes makes it robust under different illumination conditions. Go to the next slide. To enhance performance, we developed an adaptive clip point settings for Clash that dynamically adjust based on image content, and our methods considers both the most frequent gray value and standard deviation, enabling more intelligent processing of varying lighting conditions and maintaining consistent feature patterns despite variations. Go to the next slide. To address limited training the samples, we implemented data augmentations like throws reflection, translation, rotation, scaling, and other. These transformations artificially expand our data sets, helping the model generalize better to to simple real-world variations. Go next slide. And our CNN model employs a hierarchical approach where input classes are processed by a geometric feature extractor. Similar classes are grouped, and specialized convolutional neural network models process each group other. And finally, classification is based on group-specific features, and this improves computational efficiency and recognition accuracy. Go next slide. And our CNN architecture in this slide includes convolutional layers with varying patch sizes and strides, normalization layers, ReLU function, activation function, and pooling layers for dimensionality reduction. And this parameter were optimized through extensive experimentation. So go to next slide. In testing, our convolutional neural network consistently outperforms LBP plus SVM across all processing techniques. Difference of Gaussian plus clash with CNN achieved 93.8% accuracy versus 87.4% for LBP plus SVM. And even with raw images, our convolutional neural network achieved 85.2% accuracy versus 78.5% for traditional methods. And dual gamma correction with convolutional neural network showed 82.5% accuracy. Go to next slide. And higher augmentation volumes led to faster convergence and better accuracy, and overall recognition accuracy reached 95.8% with 93.2% in low light, 96.7% in medium light, and 97.5% in high light conditions. We testing used the color ferret database with various facial characteristics and expression and additional samples. Go next slide. The scientific novelty lies in our comprehensive approach to face recognition using convolutional neural networks with improved accuracy under varying conditions, and the practical significance extends to security, access control, and mobile applications requiring high recognition reliability. Go next slide. And finally, in conclusions, our convolutional neural networks model consistently outperforms traditional approaches across all preprocessing methods. DOG and Clash preprocessing achieved the highest accuracy with our convolutional neural networks model, with average processing time of 0.45 seconds per image. The system enables real-time applications in security systems, access control, and other domains requiring reliable face recognition. And the next slide, thank you for your attention. I will be happy to answer any question about our research.
Dear colleagues, I want to ask about one question. Please return back to your table, comparison table. In your presentation.
Thanks. Thank you for your question.
Just a minute, please.
Yeah, go to slide with table.
Yes, not slide. What? This is testing of
previous,
yes.
Yes.
In this table, don't understand this parameter is increase or decrease, improve or not improve, and where the comparison. Can you explain me about
metrics like accuracy? We use such of methods like LBP, Clash, histogram equalization, clear, and dual gamma correction. And we compare support vector machine and convolutional neural networks for similar tasks.
It is not understandable which parameter will be increasing or was increasing in your system. in your
For training, yeah, we used a batch size of 180 or 28 and trained for approximately 75 epochs. Also, we observed the convergence typical occurrence about 60, 65 epochs. We employed an ADAM optimizer and used learning rate 0.001. So is it all?
Yeah, thank you so much.
Thank you.
Thank you so much. Thank you to all participants. Thank you so much. Today we finished our section, day 1, and tomorrow we will continue our section number 3. Okay, thank you so much.